Hi, my name is Preston Campbell with Penn Valley Pump Company, and today we're going to be going through a tear down and rebuild session on our 6-inch double disc pump that we have in our test rig here in our factory. But first what we're going to do is go through an overview of the technology, explain how it works, go through the components review. We'll talk about where it works in an industry as far as where it's applied and not applied, and give you a good overview of how to do this.
Hi, my name is Steve Truitt with Penn Valley Pump Company. Today we're going to discuss the principles of operation of our double disc pump. The pump operates using free disc technology. It creates a differential pressure between the two discs to motivate the flow from the suction side to the discharge side. In this example on our 3-inch pump, we have the suction flange and the discharge flange, so we're pumping this direction. We have a motor that's spinning the pump shaft. The connecting rods are going up and down 180 degrees out of phase, and that drives the discs up and down. As the discs go up and down, one is always down on its seat, acting like a check valve, preventing flow from going backwards through the pump. The other one is up off its seat at the high spot of its travel, and sludge is going past it. Then they switch every half a revolution because of the offset on these cams up on the drive assembly. Our pump has a very open design on the inside, so it allows us a couple of things. We pass large solids very well. We also can, because we don't generate friction by a tight fit on the inside, this pump can run dry without damage to the rubber components inside the pump. Our pump also uses an internal clack valve, which acts as a foot valve and allows us to pull suction lifts of up to 25 inches of mercury. It also holds the suction leg when the pump is off, so that when the pump turns on again, it immediately begins to pump. Just to give you an idea of what the internal components look like in a more open view, this is a connecting rod from a 4-inch pump. We'll take the disc off. This disc just screws onto the drive rod assembly. Also, the trunnion seal, which allows the connecting rod to go up and down, but keeps the sludge from leaving the pump, requires no seal water, does not have any adjustment to do, and does not leak. That's all the components to a double disc pump.
Our 6-inch pump is the largest pump that we manufacture, so everything that we do with this pump today will apply to all of our different pump models. The double disc pump incorporates a maintain in place technology that is patented. This technology allows the pump to be rebuilt in the frame without having to remove it or disturbing any of the suction or discharge piping. The maintain in place design has housings that are hinged to each other on the back end near the discharge housing, which allows for the housings to be lowered easier than having to do it without the whole weight of the casting coming down. It provides for fairly easy reassembly and disassembly of the components. One of the main reasons why you might need to do maintenance on your double disc pump is to experience a drop in flow rate. That's one of the telltale signs that it might be time to do an elastomer check on your pump. Also, the pump might have developed a leak. Normally, day in, day out, this pump does not leak at all, so if the trunnion finally has developed a leak, it'll be time to replace that trunnion. Today we'll be working on our 6-inch double disc pump. To get started on our maintenance process, you'll need the following tools: electric impact, 15/16 socket and wrench, 1/2-inch socket and wrench, 7/16 socket and wrench, 7/8 wrench, an Allen wrench set, a torque wrench set, scrapers, wire brush, a small amount of grease, disposable safety gloves, and safety glasses. No specialty tools are required. Other models might need slightly different sized tools, but the same list applies. Now we're going to do a complete tear down and rebuild for our 6-inch pump. Our 6-inch pump is the largest pump that we manufacture. This one takes a little bit longer time to do, so we normally have 2 people to do that. That process is about 2.5 to 3 hours. All of our pumps that are smaller than this will be much easier because they're lighter. So we're going to do a component replacement on these parts.
Today we're going to be replacing the normal wear and tear components, the rubber discs, the rubber trunnion seals, the clack valve, and that also requires a set of gaskets.
We normally don't do a bearing replacement or a casting replacement, as that's not typical wear items for our piece of equipment. So what we normally do is we're going to have to lock out, tag out the equipment. We've already tagged out this pump. We've already turned the power off. So what we have to do is make sure we relieve the pressure as well. By relieving the pressure, what you're going to do is you're going to close your valves on your suction side and on your discharge side of the pump to make sure you now don't have any pressure coming to it, And then you're going to relieve the pressure in the pump. You can relieve the pressure by a number of valves on the discharge side to relieve and drain it. We can also, once we know we've drained the pump, we can open up the valve on the top of our pulsation dampeners to make sure that we no longer have pressure on the pump. We're going to use the gauge readings to ensure that we no longer have pressure. The next step then, it was going to start replacing our cross member here. That takes 2 bolts, that takes a 3/4 inch ratchet and wrench. And then we're going to remove the cover on the drive assembly, and then the cover on the belt and pulley guard. The drive assembly takes 1/2 inch bolts, there's 4 of them, so a 1/2 inch wrench will work on this, and a 1/2 inch wrench will work on the cover. There are 2 1/2 inch bolts on the front side of the cover and 2 on the opposite side as well, back towards the motor on this assembly. The belt and pulley guard cover is consisting of 3 pieces. It has a front cover, a middle wrapper, and a back cover. When we do this for complete maintenance, we do a rebuild, we take the entire cover off, which is 6 bolts, 2 in the front, 2 in the back, and 2 here on the side where we have a stiffener in it to make sure the cover doesn't move during operation.
Now we're going to remove the belt cover.
So we remove the cover so we have better access to the bolts we have to get to remove the suction housing. We've relieved our pressure already. One thing we have to do is once we've drained the liner on the discharge side, we have to remove the plug here on the bottom of the suction housing. And that plug is a 7/8 socket, so you'll use a ratchet and socket to remove this plug. Once that plug is removed, the pump's going to drain out. I should say that for this demonstration, we've already drained the pump, so we have a dry pump to start with, just for time purposes. So now we're going to remove the suction housing. We removed the drain plug. We always start at our discharge end first, work our way back towards the suction side, because the hinge pins on the back end will keep the discharge end held up. We typically leave our swan neck on, this lower 130 swan that we call that, and we'll remove these 4 bolts after we're done. So the bottom housing here has 12 15/16 bolts, so you'll just need to use your impact wrench and then maybe another wrench as we get into it. So we normally start on our back end bolt here first, and we'll remove all of these through bolts, we'll call them, that do not require a nut and washer on the back side. One thing that's very important as well is that when you take the bolts out of each housing segment, if you'll bag those bolts and tag them that they were for the suction housing, it'll make it a lot easier when we put them back together, because a lot of the bolts are pretty close in size. Some are 2.5 or some are 2 3/4 and some are 2 inches. That way you won't put a bolt back in the wrong spot. So we're going to remove the through bolts on the suction housing that go around to the intermediate housing. There are 3 bolts on the front side here. There's also 3 bolts on the back side that have to be removed. When you get to the back side, when you have a side motor mount configuration, using a long extension will help you get the impact above the motor, therefore you have better access to remove the bolts. So what we're going to do now is we're going to remove the 4 bolts on the top part of the swan neck. We leave the swan neck attached to the suction housing. We'll take 3 of these 4 bolts out. Before we take the 4th bolt out, we're going to support that housing and then remove that. So I'm going to take apart the 3 on this side now.
So now we're going to take the final bolt out, and that will allow the suction housing to swing down.
Next, we're going to pull the pin on the discharge side, and we're going to, that will release the housing, and we're going to pull the whole thing out.
Next, we take the V-belts off of the pulleys, and then we'll be ready to take off the suction disc.
We're removing the belts off the drive and driven pulleys by using a screwdriver just to pop the belts off here more quickly. That requires no motor adjustment. We can do this without damaging the belts or affecting the tension on the belts. Next, what we do is you want to rotate your pulley so that your connecting rod puts your suction disc in bottom dead center, making it easier to remove. And what we'll typically do is if the pulley doesn't want to stay in its right location, then we'll use a bungee cord to help keep that pulley in the right spot. The removal of the suction disc typically takes 2 people to grab a hold of the disc, and what you're going to turn is in a clockwise fashion. You're both going to grab a hold of the disc, you're going to make sure you have your gloves on, bottom dead center, and you're going to pull in a clockwise fashion, and that disc should release off of the drive rod. And that's the removal part of the suction disc. Now we're going to move on to remove the intermediate housing, and we're going to remove the discharge disc. To get access to the intermediate housing, we have these 13 bolts around the top end here. There's 4 on this side, there's 4 on the back side, there's another 4 on the suction side pedestal. One of the key things to remember is these 4 bolts go through the discharge housing and captivate the intermediate housing. They're about 5 inches long, so you got to make sure that you remove these 4 bolts as part of this process. Yeah, so now we're doing the same thing we did on the front side to the back side of the pump, removing these 4 bolts across the top of the discharge housing into the intermediate housing. So now we're going to get access to the 4 bolts to go through the suction pedestal into the discharge housing. And this is where you also need this long extension to get down here between the pulley and the pedestal.
So now we're going to remove the last bolt on the intermediate housing and lower that housing down.
So what the key to remember there is there are 2 bolts on each side in the middle here, and they're drilled and tapped. So it's easier if you leave one of those bolts in, take all your other bolts out around your suction side pedestal and all your discharge side end, and remove this last one. So we will typically do that with our impact. And so what's going to happen now is when this intermediate housing comes down from the discharge housing, the trunnion clamp ring is probably going to fall away with it.
Then with the suction housing or intermediate housing down, we will remove the suction side, trunnion, seal, and clamp ring.
So the next step is you'll pull the upper pin from the intermediate housing that attaches it to the discharge housing. So just like we did for the suction disc, we're going to rotate the drive shaft so that that disc is bottom dead center, and we're going to use our bungee cord to keep the pulley in place, just like we did last time. The removal of the disc happens in the same fashion, where you're going to take it off in a clockwise fashion as well with 2 people.
The next step is to remove the discharge pedestal bolt. There are 4 of these bolts located in this region that will allow us to then lift the entire drive assembly up to replace the discharge side trunnion seal.
So the next step, to get to the upper side discharge trunnion, we call it, requires a drive assembly to be lifted off the discharge housing. So in our demonstration today, each frame is drilled to accept a socket and a portable davit crane. So since you have to lift this drive assembly up, we use a davit crane to help us do that. So what we'll do next is we're going to strap the pedestal assembly with the pulley. We're going to leave the pulley on. You can either remove the pulley, or if you have the ability to strap the pulley to lift with the pedestal assembly, then you don't have to take the pulley off and put it back on.
So now we will lift the drive assembly so that we can get access to the discharge side trunnion seal.
And our davit crane has a friction winch on it, so you can go forward or reverse in it. You only have to lift the drive assembly up high enough to get out the trunnion and the clamp ring.
The final step of disassembly is to remove these 4 bolts so that we can replace the clack valve. So we remove the lower part of the swan neck, which gives us access to the clack valve. The clack valve is then removed with 2 socket head cap screws using an Allen wrench. An important part of reassembly is making sure that you clean off the old gaskets so that the surfaces are nice and smooth when we install the new gaskets. So a lot of times a putty knife is helpful. The stickiness of how difficult it is to remove is just a function of how long it's been on there. Once you get the majority of the gaskets off with putty knife, you can use a wire brush to finish up. So now we have all the gasket surfaces clean so that we get a nice seal when we put the pump back together.
Before we reassemble the pump, we'll go through the components that'll be part of your standard spare parts kit. You're going to get a set of gaskets, which includes 4 gaskets. We have a square swan neck gasket. You have a clack valve gasket, a little different configuration. You're going to have a suction gasket, and then you're going to have this discharge gasket here that has a large hole and a small hole. Those are your 4 gaskets. And then from a component, elastomeric component set, you're going to have 2 discs, 2 trunnions, and a clack valve. It's important to know that the discs are universal, so they can be placed in any position in the pump. There's not a suction or discharge or a top or bottom. They're universal discs. The trunnions, universal as well. You can't put them in the wrong spot. So this is the trunnion. This trunnion is going to be made where it has the part number embossed on it, the materials embossed on it, the PVP logos on it, and there's a batch number there. There's a conical portion of this. There is a top and bottom to the trunnion. You just got to remember that all the lettering logo always goes up towards the bearing at reassembly.
So now we're going to begin reassembly. First step is to install the clack valve. So the 2 socket head cap screws that we removed earlier, we'll tighten those down here. And then we'll put the gasket on, and what we do to help hold the gasket in place is we'll put just a little bit of grease, any normal grease that you use to grease bearings, that sort of thing, general purpose grease. Put a little bit on the surface here, just to again hold it in place during reassembly. So we'll place the gasket on.
One thing we always do is we put never sees, anti-seize on each of the bolts when we do a reassembly, and we do this for all the bolts in the housing. The suction housing has a recess in it to accept the clack valve, and therefore what we do is once we make sure we have that lined up, we can get the individual bolts started into their holes here. So we're going to use an impact wrench to get the bolts tight. We're going to use a torque wrench to get them completely tight at a 70 foot-pound of torque setting. So while we have the suction housing upside down, we're going to put the plug back in it where we took it out at the beginning of the process to drain the pump. And once again, that's a 7/8 plug, headed plug. And we don't torque the plug. Now we're going to reinstall the trunnion seal on the discharge side of the pump. Remember that the trunnion has a batch number on the top. It has the logo, it has the material, and it has the part number, and that goes up towards the bearings. Part of that process is the trunnion clamp ring. The clamp ring is a compression ring that when the pedestal is tightened down to the discharge housing, you compress the outside diameter of the trunnion. This clamp ring has a flat part and a conical groove part. The groove part always goes down toward the trunnion. Also, part of the process is we're going to grease the center part of the trunnion. So when the drive rod gets inserted through the trunnion, it allows it to slip through and not bind with friction between the drive rod and the trunnion. So now we're going to insert the trunnion into the cup or the holder of the trunnion area here. And we're going to press it in just to ensure that we have it down all the way around on their circumference. And then once again, we insert the ring and center it within the trunnion.
So the discharge trunnion seal is installed. Now we're going to lower the drive assembly with the connecting rod on the discharge side going through that discharge trunnion seal. Good. And now we'll install the bolts.
So after we've lowered the pedestal assembly back onto the discharge housing, there'll be a gap here between the discharge housing and the pedal assembly, and that is normal. because it's when that pedestal will get bolted to the discharge housing that you compress that trunnion with the clamp ring and you get a tight seal. We also remember we're going to get all the bolts started here. We do not want to tighten anything up yet until we get all the bolts installed through the suction side pedestal down through the discharge housing, and that process happens when we bring the intermediate housing back up to meet it. We're going to reinstall the discs. The disc screws on to a threaded drive rod, and we're showing it out here because it's easier to see visually than when we put it together in the pump. So the disc does require grease on the top part of the conical portion where it touches the trunnion before reassembly. This is a very critical part of the process. If grease is not added to that disc right there, it'll never go on tight. The two elastomers will bind with friction and you'll think it's on tight, but after a few weeks that disc will work its way loose. If you ever have a disc that's come off and the threads are pulled out of the disc, it's because the disc was not put on tight.
And we're not putting grease on the threads. We're not putting them on the drive rod threads or on the threads on the inside of the disc, only on this top rubber conical part here.
So once that disc can be reassembled onto the drive rod here.
It's important to note that this is not a pipe thread. The way you know this disc is on tight is that when you get to the end, you hit a hard stop, because the shoulder on the drive rod is mating with the shoulder inside the core of the disc, and they stop immediately. It's not a pipe thread that you can always lean on and put another 1/8 of a turn on it. So I'll usually get it tight and then back it off and then hit it again and make sure that it's tight.
It's also important to know when this disc is screwed completely onto the drive rod and touches the trunnion, that's your watertight seal. That's the sealing device that prevents leaking from the trunnion and up through the middle.
So now that we've showed you how to do this out here in the open where it's easier to see, we're going to go to the pump and install the discharge side disc. So we're going to install the discharge disc, and it goes counterclockwise when viewed from the top.
So now we're going to grease the inside of the trunnion again, remembering so it allows it the drive rod to go through that we insert it. Then we insert the trunnion into the cavity here in the intermediate housing. And we want to press down to ensure we have it fully seated here. Steve is adding grease around the housing there so that when we put the gasket on it, it'll stick and it won't move around and fall off with us. So we're getting it lined up with the holes as best we can here. Understanding that once we slide it under the pump frame, it may move a little bit and we'll realign it once we get it under there. Now that we have the discharge pedestal assembly, the drive assembly put back onto the discharge housing, we can remove the davit crank.
So now we're going to install the intermediate housing. In order to do that, we positioned it underneath the frame of the pump. We're going to lift it up, and we're going to use a small diameter rod instead of the normal pin to first just get it temporarily pinned up there so it gives us some wiggle room to play so we don't pinch the gasket as we pull the housing up to the discharge housing. Now that we have the intermediate housing pinned to the discharge housing and the gasket installed, we're going to rotate the pulley on the pump until we get the disc to the top so that it's not in the way when we pull the intermediate casting up. We'll take the clamp ring on the suction side and we'll put it on top of the seal, the trunnion seal.
And now we're going to lift the intermediate housing up to the discharge housing. We got to make sure we keep this trunnion clamp ring centered when we put it up. Then you have to get the drive rod into the center of the trunnion. Once we have the intermediate housing raised and we've got the 2 bolts started, we'll reinstall the 4 remaining pedestal bolts that go through the suction side pedestal. And then we're going to make sure we get all the bolts started before we completely tighten everything up.
Just a reminder, we bagged all of our bolts as we're putting them back together, so make sure and grab the right ones. And we'll put all the bolts into the intermediate housing and get that tightened up here shortly. We've got a flat washer on top, and we've got a flat and a lock washer on the nut side. Now that we have all the bolts started and tightened down a little bit with the impact wrench, we'll make sure they're all at 70 foot-pounds of torque, and we'll check all both pedestal bolts, the suction side, the discharge side, as well as all the intermediate housing bolts.
So now that the intermediate housing is installed, we're going to reinstall the suction disc up underside. Remember, we have to grease this disc just like we did the discharge disc as well, only on this top portion right here. Also note that the suction connecting rod is already in bottom dead center where it should be, because we had the discharge connecting rod at top dead center to pull the intermediate housing up. So we've greased the face of the housing up where the gaskets are going to go. That helps keep the gaskets in place so they don't move when we reinstall the housing. So what you want to do is line the gaskets up with the holes.
So then we'll slide it under and pin it on.
We're now raising the suction housing to the intermediate housing, and we're going to pin it here. Okay, now that we have the intermediate housing pulled up and all the bolts are tightened down, we're going to install the suction housing. So what we're going to do is we are going to rotate so that the suction disc is top dead center here. And then now we're going to raise the housing. So we're going to reinstall the belts now on the V-belt drive assembly.
So now we're going to reinstall the drive assembly cover. There is a front and a back here. You can see there's a bigger gap on this than there is on this hole, so that goes towards the front. And then we're going to reattach it with 4 bolts using a 1/2-inch wrench. So now we'll assemble the belt drive cover. The belt guarded cover is attached with 4 bolts, 2 on this side, 2 on the other side, using a 1/2-inch wrench. Again, it's good to get all the bolts started before you torque any of them down.
Now we're going to reinstall the cross member here on the side part of the pump, and then we're ready to go back to our phase of starting to pump up. So the pump is now all back together. So what we're going to do is make sure all the valves that we open to relieve the pressure are closed. So you would shut the valve at the top of the discharge pressure switch assembly. Make sure your valves are closed on your sample port or your drain port. Make sure your valve is closed on your suction side assembly as well. And then we're ready to open the valves on the suction and discharge side. Now we have the pump back together. We're doing a complete tear down and reassembly of the double disc pump here in our shop. What you want to do is once you have it all put back together, you have to open up your valves. You're going to turn your power on. Make sure you don't have any leaks. And you're going to go through your typical startup procedure that we normally do for your pump operation. If you have any questions about what you've done today, you can reach out to us here at Penn Valley Pump Company.
Thank you so much for your time.